Welcome to this video tutorial involving absolute value equations, specifically with quadratics. So if we want to solve an absolute value equation like the one we see pictured on the screen, we need to first of all figure out where each absolute value could be equal to 0. The optimal way of doing that is by factoring each of our quadratic expressions. So on the left here, it's not a difficult factoring because the leading coefficient is 1. We want two numbers that multiply to be 10 and add to be 7. So x plus 5 times x plus 2 should work. That way we get x squared plus 2x plus 5x would be our 7x plus 10. In the next set of parentheses, we're going to look for two binomials that multiply together so that we've got an x and an x for the x squared. We need these numbers to add to -2 and multiply to -8. So -4 and +2 would work. And there's our factored equation. From that factored equation, we can identify the key numbers. -5, -2, 4, and -2. And of course, we will now turn our attention to putting each of those numbers on a number line. So here's our number line. Putting those numbers in order on the number line, we're going to have -5, -2, and +4. And it will split our number line into 4 cases. And we'll have to consider each of those cases one by one. So let's start where it makes sense to start. Case 1, x is less than or equal to -5. In that scenario, if we put an x that's pretty negative, like -100, when I square a -100, it turns into a positive. This is going to be positive overall. If you think about an x squared in general, x squared is a parabola that looks like that. If you think about where the axes might be, something like this, depending on the specific parabola, certainly when you get really far negative, as long as this is a positive x squared, the result will be positive. So in this case, we just simply take off the absolute value symbols. We get x squared plus 7x plus 10. Leave the minus sign alone that's there. And again, if we plug in a very big negative number, like x equals -100, inside of here is going to be positive because 100 squared is going to be much larger than the other items. So we still have to leave the negative out front. We don't change that, but then we just take off the absolute value symbol. X squared minus 2x minus 8 equals 3. Make sure to distribute that negative through the expression. And be mindful that you might be doing this problem and will likely be doing this problem without a calculator if it were to appear on a quiz or a test. The x squareds cancel, that's kind of nice. We get 9x plus 18 equals 3. So 9x would be a -15, and x would be a -15 ninths, which would simplify. Top and bottom divisible by 3. X is going to be a -5 thirds. Always make sure you compare it back to the case. -5 thirds is not less than or equal to -5. This would be an extraneous solution, so it would not be part of our overall final answer. Let's turn our attention to case 2. So for case 2, we're operating with -5 being less than or equal to x being less than or equal to -2. So if we took a number between -5 and -2, we would plug it in. But remember the other way to think about things. We jumped across -5, which means we jumped across that key number. The only one of the absolute values that could change from positive to negative, going from case 1 to case 2, would be this one right here. And if you think about a parabola and think about how an axis might work, it will go from positive to negative back to positive as long as it was a positive coefficient on the x squared. Or you could take a number between -5 and -2 and simply plug it in. Like if we plugged in x equals -3, 9 minus 21 plus 10, 19 minus 21 would be negative. So taking off the absolute value, we need to put a negative sign out front. And notice I keep going back to the FOILed out expression. That's easier to work with than the factored expression. It's just we needed the factoring to find the key numbers. The other absolute value stays as it was in case 1, and this is equal to 3. Make sure to distribute each of the negatives completely through your expressions. So we're going to have negative 2x squared minus 5x minus 2 equals 3. Personally, I like the x squared to be positive, so I'm going to bring everything over to the right-hand side. 2x squared plus 5x plus 5, it looks like. In general, the best way to solve that is through the quadratic formula, where x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Of course, such a formula will not be provided to you on a quiz or a test. This is negative 5 plus or minus the square root of 25, 5 squared, minus 4 times 2 times 5, all over 2 times 2. So negative 5 plus or minus the square root of, what's this going to be? 25 minus 40 would be a negative 15 all over 4. For the purposes of these problems, we're looking for all real solutions. This is not a real solution here, so there are no solutions in case number 2. Again, we're looking for the real solutions. We're not looking for all solutions, including those with i's. Let's scroll to case 3. And by the way, if we did want solutions with i's, that would be clear. It would say find all complex numbers. So for case 3, we're going to go from negative 2 less than or equal to x less than or equal to 4. What's the difference between case 2 and case 3? Oh, both of those absolute values contain the key number of negative 2. So both of those absolute values will change. This is also an easy case because we could plug in x equals 0. Plug in x equals 0, the first absolute value is positive, so it'll just be x squared plus 7x plus 10. X equals 0 makes the second one negative, so the negative that was there, throw in another negative sign, and really we're just going to be adding that second expression. Set it equal to 3. Clean things up nicely. I can change that into a plus and be shortcutting it. We have 2x squareds plus 5x plus 2 equals 3. And let's make this plus sign look better just for everybody who's staring at the problem as we go. Get everything on one side, so we'll have 2x squared plus 5x minus 1 equals 0. Now maybe it factors, but in general it's negative b plus or minus the square root of b squared minus 4ac all over 2 times a. And in this case, that's going to be a negative 5 plus or minus the square root of, c was a negative 1. Be careful on that. Almost made a mistake there. 25 plus 8, I think, is 33 all over 4. Now, really, there are two solutions there of which we would be mindful. X would be equal to negative 5 plus radical 33 all over 4. Or x would be equal to a negative 5 minus radical 33 all over 4. We need to check each of those against the case. So when we keep in mind that the case was negative 2 is less than or equal to x is less than or equal to 4. Guesstimate things a little bit if you don't have a calculator. Square root of 33 is going to be somewhere between 5 and 6. So this is going to be something like negative 5 minus 5 all over 4. Which is negative 10 over 4, which would be negative 2.5. That would not fall in the case, so this one is not going to work. Of course, on a test or a quiz, make sure that I'm able to read what the answer was. On the other hand, over here, this one is going to work. Negative 5 plus 5, it's going to be close to 0. It's going to be close to 0, which is certainly between negative 2 and positive 4. So negative 5 plus radical 33 all over 4 is certainly one answer. But now we need to look at case 4. So we will scroll over here and get an IV as we go. Case 4 is going to be that x is greater than or equal to 4. What could change from case 3 to case 4? The second absolute value, because that's where the key number is located. So if we put in a really big value of x, like x equals 100, that first absolute value remains positive. Inside the second absolute value is going to become positive as well. So we leave the negative that was out front and take off the absolute value symbols. Make sure to distribute the negative as we've said before. So we get x squared plus 7x plus 10 minus x squared plus 2x plus 8 equals 3. I think this is similar to something we had looked at before. The x squareds cancel. We're going to have 9x plus 18 equals 3. 9x is equal to a negative 15. X is negative 15 ninths. This does look eerily familiar to our first case. Divide by 3 and x is negative 5 thirds. Clearly, negative 5 thirds is not greater than or equal to 4, so that is not an answer. And it's not uncommon for one case to mirror another case, so don't freak out if that were to happen. Don't forget to write your overall answer to the problem. There was only one solution here. It was in case 3, where x was negative 5 plus radical 33 all over 4. So there would be our final answer, and we would be good to go. Now, a lot of times that might even be nice to split into x is negative 5 fourths plus or minus the square root of 33 over fourths. This was not plus or minus that worked, it was just the plus. But a lot of times that's the preferred way, perhaps, to simplify expressions resulting from the quadratic formula. Overall, the main key is to make sure that you get the key numbers found correctly, factor, put them on the number line, and then consider cases one at a time. That should help you be able to solve absolute value equations involving quadratic expressions.